Good evening, everyone. I am R. Vishal, event host at AWS Cloud Club, St. Joseph Groups of Institutions. Welcome to the Cloud and DevOps Masterclass, Episode 2, DevOps Tools. We are pleased to welcome Mr. Mohammad Asim Akram, a distinguished software professional in cloud computing, AWS, and DevOps engineering from Insight Therapy Solutions. He brings expertise in cloud architecture, Terraform, Ansible, Jenkins, Docker, and Kubernetes. As a tech content creator on YouTube, he shares his knowledge and inspires the tech community. With extensive experience in building, monitoring, and scaling AWS infrastructures, Mohammed is a subject matter expert in cloud technologies, CI/CD pipelines, containerization, orchestration, and release management. His innovative approach will provide valuable insights to help us advance technology and achieve our goals. Thank you all for joining us. Your enthusiasm makes this initiative impactful. I am confident that today's session will be both enlightening and empowering. Now, without further delay, I hand it over to Mr. Mohammad Asim Akram to lead the session.
Thank you, Vishal, for the great introduction. Okay, so most of the points he has already covered. So let me introduce myself. My name is Mohammad Asim Akram. I have been in this industry overall from the 10 years plus 10 years. Okay, I have been to different domains with the IT industry, working on healthcare sector, automobile sector, e-commerce sector projects. Okay, the current I'm handling for the healthcare products. Okay, we are making products as we are working as scratch from the scratch to the delivery to the clients. Okay, I have been part of that. I have been handling cloud infrastructure completely, and I'll be part of DevOps, enhancing our products, speed up our delivery, and this is my responsibilities. Okay, I'm the content creator. When I get free time, I make videos on the YouTube. You can find over there. Okay, I missed out to open my camera, right? Okay, sorry for that. Okay, so this is my responsibility. Okay, today I received the opportunity from your host that to host this session. So I'm grateful that he have given me opportunity. So I want to make this master class of the DevOps tools more meaningful and to be to the subjective and add as a lab also, as I mentioned before. Much ado, let's go and start about these sessions. Before we start up the sessions, as I received the information from your host that we already have covered the DevOps tools as infrastructure as code Terraform, right? Where we write the infrastructure as a code and we create our infrastructure, destroying infrastructures on AWS or another cloud providers. And we already covered, as I received the information, that Docker. Okay, so this session is, let me share the PPT. Okay, so this session will be covering for the Kubernetes, right? For the Kubernetes session. What are the prerequisites in order to proceed further for the Kubernetes? We require Docker. Okay, and already you have covered the last session as I received the information about the Docker. What is Docker? For the simple terminology, Docker is a containerized application. It will pack your application and it can be deployed in any environment without any dependency. Okay, it is portable. You can take a Docker image from the Docker Hub. Okay, it might be private repository, public repository. With the credential, you can deploy your container. Okay, so now the point is that why we are the Kubernetes is emerging in IT industry, right? When we say Kubernetes, there might be some reasons, right? It might be why, what is Kubernetes, why Kubernetes, right? So this session, we will go first on this, why Kubernetes is, okay? And how this Kubernetes came into the play in the IT industry and it was involved. And this is a present, this is a future, okay? So I'll give the present, go with the next slides, okay? And I will continue. So let's start. Okay. See, I'll show you something. Are you aware of the movies, right? Do you have watched, I want response from you students also. Do you have watched Pirates of Caribbean? Movies, the series, which is Jack Sparrow?
Yes, sir.
Yes. Do you see that you have noticed there is a fight for handling the wheel of the ships, right? Do you remember whoever take over the ship, he is the captain of that ship and he has all the controls. Do you notice that part? Anyone? Okay, no issue. When you overview after this session, you just check out. There is a multiple scene in that. There is always a fight to hand over this ship. If you check it over here, the wheel of the captain, right? So whoever handle this wheel, he has control of everything. Okay, so this is something like this. If you check the Kubernetes wheel, this is same scenario with this itself. Okay, so what do you mean by this? Okay, let's go here. So the word, the Kubernetes, right, it's known, usually it's derived from it known as a pilot and the helmsman of the ship, as I mentioned over here. The same scene, it might be inspired or it can be coincident, but the part is that whoever has this control of the wheel, he can do anything. He's a master in that. Okay, the same concept they have used the logo of this Kubernetes. The point is that he's controlling this wheel, and he's the master, right? He's a captain of the ship. In this case, if we have the Kubernetes control, what he can captain, right? He has the access of Docker containers, right? He, whatever the application is hosted in Docker, right? Docker container, the Kubernetes has all the control, the mastermind and everything to manage, to deploy, auto healing, auto scaling and everything. So this is this is the overview which you can keep in mind whenever you say Kubernetes, that is has a control of the Docker container, right? So let's go for the next slide. Okay, now why the Kubernetes is very important? This is the mandatory skills in the current scenario of the DevOps engineer. Okay, in the current market essentials, if you check any job hosting, you will find that Kubernetes is required, the tool, right? So this is this is a crucial requirement and highlight required, right, for the IT industries. So you should have the skills of the Kubernetes. Okay, if you check any job, like say, let's go for the Naukri.com. If you check only one, let's say 10 sample, you will find mostly in the 8, you will find Kubernetes has to be added in your skill, okay, in your resume. The reason for that is, everyone is looking for the complete DevOps engineer. Without the Kubernetes, you can be a better release engineer, you can be a platform engineer, you can be as an automation engineer, but still you cannot be a complete DevOps engineer in current scenario. Even as irrespective of DevOps engineer, even as a developer also, in some industries they were asking for some MNC companies, they are asking the skills of Kubernetes. Okay, so you understand why Kubernetes is emerging and is required, right? If you go for the Docker history, as I mentioned before, okay, Docker, usually you're containing your application, right? So whatever your application is there, you are taking one EC2 instance, maybe you have covered in last tutorial, right? As I mentioned. So you will package your application, you will deploy that application into any EC2 instance, and you will make the 10 containers of your application, okay, Docker containers, and you will host your application in the EC2 instance, right? For example, let's say one Docker container, your application container get crashed for XYZ reason. It can be any reason. It can be any DDoS attack on your website for the application. It can be a load, CPU consumption is very high, right? In this case, what will be our step? If you are not going with the Kubernetes, then our step is that we have to go manually into EC2 instance, right? The VM machine. Then we have to look out which Docker container is down, right? We have to check that logs of the Docker container. Do you agree with me? And we have to check that point, what does it cause the Docker container to scratch it? Okay, then we can spin up, we can restart this Docker container, or we can create new Docker container because we have the images, right, with that our Docker images of our application, right? And we can do that part of that, okay, to make your application more scalable. Let's say we are going for the 10 to 15 Docker container of your application, you can scale up this part. But the thing is that you require the physical attendance of the engineer. In this case, you have to be available, you have to go, you have to check out into EC2 instance, then you have to check what's the reason it caused our Docker container to kill or destroy or stop of your Docker container. You have to check the logs, you have to debug and make your container up and running, right? So does engineer is always available to 24/7? No, right? So in this case, what happened? Then the come of the Kubernetes. Kubernetes provides you, auto healing part. Whenever there is a container, when I specify that my application should be working with the 10 containers, right? For example, when 10th container get destroyed, then the information passed to the control of Docker Kubernetes. Okay, sorry, Kubernetes control panel. Then it will spin up one more container. It will add that container, make it applicable, accessible. So now the count's gone from 10 to, from 9 to again 10, right? From the 10, 1 is minus, right? Then it became 9. So what happened? Kubernetes will make it that again 9 plus 1. Okay, so then again, what we have required, this is our motive to have 10 containers of application, that is already healed. Okay, this is one use case. Second use case, it can even make it auto scale based on our traffic to our application. What do you mean by auto scale, right? So let's say I'll give one more very, very best example. Do you watch everyone cricket, right? Do you agree with me?
Yes.
Yes. Yes. So do you remember when Virat Kohli plays his match and he breaks the Sachin record? The day the viewers of the hosted application, I think it's what it was Hotstar or Geo Cinema, I don't remember, but the point is that at that time the view was 4.5 crore. You know the application view, approximately 4 plus crore, which was the highest viewership received on any Indian any sports viewership. Okay, what was the behind of that? Do you find this gimmick? That's the play was Kubernetes. Okay, whenever the request coming from the client in the sense I'm referring to the user, when the user is accessing their application to watch any application, right, to watch anything like cricket, so automatically Docker, the Kubernetes start creating the container for the users. Okay, that containers is known as pods. Okay, in the Kubernetes terminology. So what happened based on your scaling up the user viewership? Okay, based on the viewership, let's say our viewership is increasing like this, right? So we have to match this, right? So our application containers goes the same way. Whenever there is a drawback of the viewership, and you remember that when the match was at the end, right, after this, and I think he was out, I don't remember, but what happened? The gradually the viewership's gone down. Okay, so at the time that same should happen with our resources also, it has to come down, or else we will ended up paying huge cost of our infrastructure, which is not accepted in IT industry by any organization, right? When we say DevOps, when we say cloud architect, right, they're going with the first step, delivery of application should be enhanced. Second is cost optimization, right? So based on our load of our viewership or the client, the application should perform. Based on the drop over the client, the application should goes down. You got my point? So this is the player, the behind this, there is a player is a Kubernetes. Same goes with the Netflix, same goes with the Hotstar, same goes with any hosting application which you see in the viewership. FIFA hosting applications, you everywhere will see the Kubernetes is the main player. Okay, the same thing happens with the big billion day. Do you remember the big billion day? How many the users come to buy the things on that use case on your on the applications? Let's say any application, Amazon, any Nike, anything else, you will be huge, right? So that your application should scale for that event eventually to handle the traffic. Okay, in this case everything is come with the Kubernetes. Okay, you got my point why now the Kubernetes is very important when we can go further with these sessions. Okay, so Kubernetes will monitor your containers in terms of application container into 24/7. Okay, and in the Kubernetes we can mention the specific resources of your to your application also. Let's say one container or one pod can have 4 GB RAM, right? So based on the load, if it increasing on that specific container, eventually it has to auto scale. Okay, you got my point. This Kubernetes will load to traffic to scale the container with the copies of our application and selfie. Okay, and the second point is why Kubernetes has been adopted in the industry is that this is open source. What do you mean by open source is that this is freely available tool. Okay, so and let's go for the history again. Let me cover one more point, then I'll cover. Okay. So the thing is, now if you see the Docker versus Kubernetes, what's the overview of this discussion? Docker is a platform which enables developers to automate the deployment of the application using lightweight or the portable container. Okay. Just you convert your application into the Docker image, then you create Docker image to the Docker container, and you deploy to your environment, right? Does not the Docker does not solve the problem. Like single host EC2 instance, as was specified, it can be have multiple container. Whenever we require, let's say our container is down, it cannot provide auto healing, right, without user intervention. Somebody has to look over there. You require 24/7 resource of one engineer or anyone responsible for that person. Okay. And auto scaling, whenever the increase in our load of our application, as I mentioned, reference to cricket or any event, then it cannot scale up to that. Okay. And the Docker is not is a production uses. Okay. Singly, if you're going with the application with the Docker, it's not recommended to go for the production. In the production is always a combination of Docker plus Kubernetes. Okay. Docker simple platform. If you check it over here, the Docker, it will provide you one IP, right, of the EC2 instance IP, right? And it does not restrict, there is no such firewall is allowed in the Docker, right? We cannot whitelist any IP address, restrict IP address. We cannot API gateway, or during the DDoS attack, if you found any IP, somebody is trying to put my application in the danger, putting DDoS attack, okay? Distributed denial services, okay? The DDoS referred to. So let's say in the market, you have to keep your application very secured. There is a lot of, there is a healthy competition and there is unhealthy competition also. If we are getting our booming our application and we are emerging, there is a lot of competitors who do mischief things and try to put your application down. Okay, try to destroy your application down. They can do anything. Okay, so that one of the thing is that they will send a lot of traffic on your application at a water time from the different IP. At the time, automate, you have to pick that IP which is doing mischief thing, and you have to block that IP for your access of your application. Okay, this kind of thing is missing from the Docker. So these all solutions come with the Kubernetes, but still Kubernetes always has been emerging. Okay, so they'll be releasing the latest version is 1.30, but last week they have released new version that is 1.31. So they are already working on this continuously. Okay, so let's go this already. What Kubernetes has come with that? Kubernetes is a container orchestration tool. Okay, it can provide you the load balancing, self-healing. As I mentioned, that the load can be distributed to multiple working nodes or the different pods, and the self-healing. Okay, whenever the container is down or your pod is down, right, in the pod the container will be done automatically. It will scale up, as I mentioned before. Okay, high availability access deploy complex deployment. I say that it can scale highly. Okay, so whenever we make multiple pods, multiple worker nodes, we are referring to high availability of our application, right? So this part is done. Okay, now let's go with the Kubernetes. Kubernetes, as I mentioned, this is open source and it is highly adopted, right? It's used to design, deploy, automate your deployment, scaling, management of containerization application. Okay, it required effortless management in the sense is automate your deployments. As I mentioned, that it can be, it can be deployed on the physical server. It can be deployed in any cloud providers, right? Seamless integration of your application like Kubernetes. It is adopted by AWS also. They are providing EKS, right? EKS they are mentioning, Azure, AKS they are mentioning for Azure. The Google also, they have Google engine, right? Google Kubernetes engine. So this is how they have adopted with the major player. Even if you're going for another core cloud provider, okay, let's say for Oracle, even they have this one. Even you have another Linode, even they are trying to bring this one. Okay. Now let's go for the Kubernetes. Okay, Kubernetes is actually developed by Google. This is a product of Google. They used this as an internal system, like an internal tool for their Google organization. Okay, then they called this name as a Borg. Later they renamed as Omega. If you go for the Kubernetes history, you will find this the history of the Kubernetes. Then afterward they try to making their application, Google application, billion of containers and deploying different environments, and they found this is very successful as their internal tool. Then they decided that it has to be evolution. They donated to one organization that is known as free organization CNCF. Okay, this is the first project that is donated to CNCF. So CNCF is responsible for maintaining now the Kubernetes. Okay, So as they are the receiver of this donation, they are maintaining everything. They are fixing the vulnerability of this application. They are fixing everything. They are maintaining development of this application, and they are making up to the standards of the IT industry. Okay. So it was released in the production version as 1.0.1 in 2015. It has been around 10 years, right? So in 10 years, this application got boomed. Now every in IT industry, in the IT industry, every organization is adopting this tool Kubernetes. Okay. So let's go for the project. Okay. I'll show you this. Okay. When we say open source, right? What do you mean by open source? If you click over here, uh, I'll show you the thing. This is what the GitHub link of this project. Okay, Kubernetes. So let me go over here. See, this is the official repository, which is public, right? This is a public. If you want to be a contributor, you can take a pull request. You can add whatever you can contribute to them. If you check it over, there are 3,600 contributors. These are the contributors these to Kubernetes. Okay, this is up to date. The latest version is 1.3.1. Okay, they have released in 4 days ago. So this is update up to the they are getting the releases. How many releases they have? Almost 700 releases. In every 2 weeks to 4 weeks, you will receive one new Kubernetes version with fixing all the things, new updates, new options available which you can integrate. Okay. So this part we already showed. This is available publicly. That means that is open source. Okay. Switch back to this. As I discussed, this is a repository, right? This is an active open source project, and it's received 190K stars. Do you believe this? If you check it over here, how many stars that they received? See, the stars for this repository is 1.9K. This is huge, and the folks are 39K. That means this is very meaningful application, right? Fine. Okay, now the part is that now the Docker and Kubernetes came along with that to make Docker containerization of your application and Kubernetes as a deployment. Okay, and they are working together. We require Docker expertise to in order to proceed for the Kubernetes. Okay, so you should be perfect in Docker. Then you can work on the Kubernetes. This I will show you why I say that Docker prerequisition is required for the Kubernetes in the lab, which we proceed in the second half of this session. Okay, so now let's go for, as I mentioned, that it's a self-healing, right? For if you give the one use case, right? Let's say that I am requiring my application to be three health instances, right? Of my application, always running. Whenever, let's say one is down, so Kubernetes, what will do? It will ensure that always three instances up and running. Okay, instance in the sense pod. I'm referring to the pods or the containers. Okay, don't get confused for that. Okay, one is dead. It will automatically attempt to spin up with the new one. This we will try in the in the lab also. Okay, we will try to destroy and we will see does Kubernetes will validate this point. Can we authenticate that? Okay, this is happening or no? Okay. For the theory part, let's cover this point. Okay. Now the key concept of this is, as I mentioned, that pod. The pod you will be finding in this tutorial always to the end of this tutorial, the word as a pod. Pod is the smallest component of this Kubernetes architecture or the part of the Kubernetes, where you will host host your Docker containers. Okay. The main part is a Docker container will be hosted in pods. Okay. You get this point in the architecture. I will explain further point. Okay. So now let's go for this part where I'm 16th, right? Okay. See, let me just switch it over here. This is the architecture of the Kubernetes. Okay. Can anyone respond that I'm audible clearly for everyone?
Yes, sir. Audible,
Yes,
sir.
sir.
Okay. Are you able to get the points what I have been specifying here? Is it easy or you want me to be more easy?
Yeah, sir. We can able to get it, sir.
Okay. Okay, you are able to get. If you feel any point that, just sir, can you be more slow or easy, please don't hesitate. Over here, the point of this session is to give some knowledge, to gain some knowledge. I'm also always getting some knowledge from everyone. Like, I share the knowledge, is informative for me, that I gain some knowledge, right? So don't hesitate, everyone is welcome, they can give their points. Okay, so this is the architecture of Kubernetes. Okay, if you check it over here, then you will find there is a one block over here and one more block is over here. It's mentioned that node 1, node 2, and this has a control panel. Okay, so let me add some history for this. Before, it was known as master slave concept. Okay, master slave concept of Kubernetes, like the same reference to the point of Jenkins master slave concepts, right? Okay, then later on there is some US, there is some agitation gone, they say that we don't prefer the word slave. Then they came up with the solution that, okay, we will say as a master and a worker. Okay, so this is a master, this is a worker. So if I go for the one hierarchy of our organization, right, let's say example of our XYZ organization, whenever the task we receive anything as a employee, right, we receive from the manager, right? Do you agree with me? Your the hierarchy always in the organization is that you will receive your work, right, from the higher position of you. Okay, so in this case, this is the person. Okay, he is the lead. Okay, let's say that control panel, he is the lead. So he will decide and he will do everything. These are the workers, they will follow based on his request. Okay, you got my point. This is a master, these are the workers. Okay, you can say control panel and the nodes, worker nodes. Okay, so whenever the request comes from any, let's say from the owner, then the request has to pass to your manager, right? Any request, then manager will decide which of the employees should handle this request and execute and provide the information to the manager, and then manager will revert back to the client saying that this request has been successfully done. This is a hierarchy which we've been followed in all the organization, right? So it can be different, but this is a usual hierarchy. Here also the same thing happened. Okay, this node 1, node 2, there is no access of internet for this one. Okay, this is only accessible within the cluster. When I say cluster, cluster means this is a whole architecture. Cluster refer to the group of servers, right? It's a group of server. This is a one server which is a master. There is a one more server which is a worker one. This is node 1. There is a one more server, EC2 instance, you can call it as VM, as you can call it, right? This is node 2. So complete structure is known as cluster. Okay, whenever the request coming from anywhere, the request first will pass to Kube API server. Okay, then Kube API server will pass to the information to nodes of the worker, whatever the request is come. So now what we will do it, we will just go deep down and we will see, we will cover first point as a worker, what they are. Okay, actually, if you see here, there are the multiple components, right? There is a pod. As I mentioned, your container, Docker container will be hosted in pods. Okay, this is the smallest like component in all the architecture. If you check over here, this is the smallest particle. It has small block also to refer that which is the smallest component. If they ask you in the interview also which is the smallest component in Docker, in Kubernetes architecture, you have to say is pod. What's the use of the pod is that it will be hosting your Docker containers. Okay, your application containers. Okay, so this part is clear to you, right? And the thing is, the next we will cover the kubelet. Okay, kubelet, what's the part of the kubelet? Okay, kubelet is responsible to create the pods. Okay, so it can create multiple pods. Whatever the task he received from the master, it will execute. Kubelet will execute this part. Okay, and one more part, kubelets, what we will do it, always check if our pods is up to date or no. That means is accessible or no. It will check some of the health check and it will know that the container is accessible, is working up, is up and live. If there is some issue with our containers, is container is down or the pod is down, there is something happen with the container, the information it receive and it will pass directly to the Kube API server. Okay, so the connection of this and this, all these two blocks is going with the API server itself. This I will cover it later. The part you just try to understand, Kubelet is responsible to check out your containers is up to health or no, right? Is okay, is working, the condition is fine, it's up and running. Is there any crash based on the resources which has been specified is down or something? It can be XYZ reason. If it found anything mischievous over here, okay, let me add with it. Let's say I have said that this pod should have one container, this should have one container, this should have one container, one container of my application. The application, let's say I'm hosting over here the bingo application. Okay, this is a bingo is a game, you are aware of that, right? The bingo application I'm being hosting in this pods, right? One container, it can be multiple container based on requirement. You can host two container in the one pod also, but it is recommended to go with the one container only. Okay, but based on the organization they can specify, but in our use case we will go only with one container. Okay, so now what happened, we have four container in two worker, one worker is over here, one worker is two over here. So let's say one container is gone for any XYZ reason. The reason that, let's say I have given 4 GB RAM, but my traffic came huge, right? So the traffic distributed for over here, suddenly my container got down. So this information will be passed to Kubelet. The Kubelet will automatically send this signal to Kube API server. Okay, then it will revert back and say that please spin up one more container instead of this. And each pod has unique IP of a unique IP address. Okay, so whenever this containers gets this pod gets destroyed, okay, it's get new IP. Okay, it get new IP. So our use case was to have four live containers, right? Four live containers, or let's say four live containers of our application. It gone to three, then suddenly it gave that command, please Kubelet spin up one more container to match our minimum requirement of our application. Okay, how you specify this, everything we will specify in one file, which is .yml. Okay, which I will show you in the lab. Okay, don't worry how you will define that, what should be my minimum containers or the pods should be there, and what should be maximum. Okay, so this we are specifying in one file. With that file always will be up to date, and it will say Kubelet please go and make it 4 is equal to 4. So it will spin up 4 and 4. So this is the part of the kubelet. Okay, so now if you check it over here, container runtime, right? If you check container runtime, this is nothing but this is referred to Docker engine. You know the Docker engine architecture, right? So we are on the Docker engineer engine, we are hosting right our Docker containers. As you go for the Docker architecture, the containers are hosted right above the Docker engine itself. The Docker engine is interacting with the Docker container, the Docker, and it will Docker daemon, and it will create the Docker containers. So as we are hosting the Docker container itself inside the pod, so here the Docker runtime referred to that. Okay, and the point next, as I mentioned, that Docker kube proxy, right? The kube proxy, what's the meaning of the kube proxy, right? Kube proxy is responsible for managing the network of the cluster, Kubernetes cluster. So whatever this IP you are getting of the containers, right? We have four. This everything will be stored over here, copy proxies. Okay, kube proxy is responsible for that. And whatever the communication going between the pods, okay, let's say two pods or these pods, if everything is paused with kube proxy. Okay, to make it more easy, I can give you one more example. If you're aware of Nginx, right? Do anyone have the information about Nginx? This is a very powerful web server. Can anyone respond? Can anyone respond? Hello?
Yes, sir. We just have a basic idea what Nginx is based on using usage with Docker, but not as a whole Nginx.
Okay, so let me add, let me add the few points. Okay, the Nginx is a very powerful web server. Okay, and web server I'm referring for reverse proxy. Okay, so it's a reverse proxy, powerful engines where you defined, okay, let's say asim.com, I have a domain, right? And I have a front end, I have back end, Let me add over here. Okay. Let me delete. Let me, where is the pen over here? Let- Every application has a front end, right? Do you agree with me, everyone? Then there is a backend where you specify the hierarchy or the APIs and everything, how it should respond. Okay. Then you have a database where is a heart of your application. Let's say I have an application with the name of Asim and it's accessible with asim.com, for example, for the use case. Okay. Whenever the request come here, if it's coming from the front end, the GUI is the front end, right? It should pass to front end. Okay. From front end, it has passed to the, if they are want to access my any blog, let's say I have a blogs or the post over here. So the front end will pass to the backend. The backend will hit the database because my all news articles are been stored in the database, will fetch this one and it will pass to front end. The front end will be displaying over here the news channel, right? If you check any news website, you will find the same thing happen in the back end. This everything will be happening. This is this three front end, back end and database will be hosted separately. Okay. Let's say for example I'm hosting 3000 in one 3000 port. I'm making front end, the back end is making on 3010. The database is not open to public, that means it's secure, right? So the request I cannot give like IP address with 3000, right? How I can give any user? You say that somebody come, Asim, I want to access your application. So what I can give to them? I can give my URL, right? asim.com. So I cannot give IP/3000. I'll say that please, Rohit, go and access IP plus 3000. You will find my front end. Please take my IP plus 10,000. You will find my backend. So this is not possible. In this case, what happened? I will make one Nginx configuration file, right? With that file, I will specify multiple rules. With that rules, everything I will make is as reverse proxy. Whenever the request coming from here, from my domain, that has to pass to all these running applications. Okay. So the same thing happens. Okay. Same thing happens with the with the kube proxy. Okay. So it's responsible to communicate within the pods. Okay. Within the pods, it can communicate with the pods. It can get all the IPs from that pods. Okay. Communication between a multiple pod of your application, right? It can even make enable cluster load balancing and service discovery and anything. Okay. And this is the part of worker node. Okay, you got my point. There's a major three things: kube proxy, runtime, and kubelet. Okay, the service in the sense is that IP address, as I mentioned, thus in this part, this is not accessible from internet. Okay, this is very secured. It is only accessible within the cluster. Cluster, I'm referring this for this part complete. Okay, bunch of control panel, master, and the worker nodes. Okay, so what happened, this has a one IP, as I mentioned, that every pod has one IP, right? But even it cannot be accessed from the internet. Okay, so for that use case, what we will do it, we will make a service. Service will have a one load balancer. Okay, you know the load balancer, right? EC2 load balancer. The load balancer will have one DNS. With DNS that we can access. To make this everything, we required Kube API server. Okay, so now this part is clear to you, right? So let's go for second part. The second part is we have, this is very important. This is as a master, right? This is a master control panel. Okay, if you check in the master control panel, you're able to see that there is a one cloud control manager. Okay, then you have Kube control manager. You have Kube scheduler, Kube proxy, and additional services. Okay, then you have Kube API server. Okay, let's go with one. Okay, so the first point, the Kube API server. Whatever coming, the request is coming from outside of the world, from the browser, from EC2 instance, right? If I want to create this cluster, right, a complete setup, the request first pass to Kube API service, right? Kube API server will check it out. I'm authenticate to access this, right? Authentication will go, the part first authentication, then the request will proceed to master node, right? All the information what is processing, that will be stored in etc. Okay, whatever you are doing, everything that information stores in etc. If you go for Linux operating system also, right? Ubuntu or any other one, you're able to find one directory is ECT by default. Okay, whatever the application you're going to install, that it will make all your configuration files inside this etc directory, right? The same you can refer for to remember. Okay, just to make it remember and make it easy, whatever the information that Kube API server receives, that stores in ECD. Okay, so usually Kube API is a gatekeeper. As I say that whatever the request is coming, so this is a gatekeeper, this is a security guard inside the cluster and to the internet. Okay, because the internet request should pass from here, the browser request, or I'm accessing EC2 instance, I'm integrating this cluster with Terraform, with Jenkins CI/CD, any XYZ, that request should pass with Kube API server only. Okay, so this is a gatekeeper which will receive your information, which will authenticate, then it will proceed further. So this is how your complete Kubernetes secured this way. This is a very secure application. Okay, so now if you go for ECD, as I mentioned that it stored all your backend of the Kubernetes. As I mentioned that whatever has been happened inside this Kubernetes cluster will be stored in the ECD. Okay, and ECD can only access, right? Who has this access? If you check this line, it has only access to this controller itself. This component of Kube API server can only communicate with ECD. This is how secure. Even this another components or the node worker, it cannot communicate with this. Okay, only Kube API server, it can communicate with it. This is how more secure it is. Okay, now let's go for second one. Okay, let's say Kube Control Manager. Okay, what is done? Okay, so it's a home of the controllers. Okay, whatever the controllers, if you check it over here, you have multiple controllers where Kube Proxy, Runtime, Kubelet, and everything. So it's control everything. It's act like a manager inside the Kubernetes cluster, right? It will handle all the core controllers. Let's say if I'm going with the anyone replica set, I want to make it one instead of one container, or the pod I want to make it two in the future, right? So this all will be handled by Kube Controller Manager itself. Okay, it's controlling all these things. The information pass from here, then it is put here, and the request will be entertained. Okay, so what do you mean by Kube Scheduler? Kube Scheduler, right? This is a very important which you may get in the interview always. Okay, so the Kube Scheduler will decide, right, where our pods will be deployed. Okay, let's say in my YML file, I specified that my application, which is Bingo, right? I required 4 pods of my application, right? 4 pods of my application, right? Let's say 4 pod. So then Kube shell, the request when from here using kubectl, I'm making configuration file, then I'm hitting this control panel, right, to the for Kubernetes cluster. Okay, then the request come here, then scheduler will check which worker node is free as the manager, right? Whenever the request come to the manager will check out which worker is free, he don't have the workload extra. Based on that request, the manager will give that employee to work on this specific task. The same happen with the Kubernetes scheduler, is responsible to distribute the work or the pods, okay, to deploy the pods in the nodes, node worker node 1, worker node 2. Okay, so this part is over here. Kube Proxy, as I mentioned, that this is the same which will be handling over here, right, responsible for that. Okay, as I mentioned. Now if you check the placement of pods, I mentioned, right, is responsible to Kube Scheduler. It's responsible to handle this node 1 to deploy all your pods in node 1 or node 2 based on the request. It's always check. Let's say I'm going with the request 3, right? Let's go with the 3 pods. So what happened, it will just check with the help of Kube API server with the kubelet. It will fetch the information. Does this node has only one, this node has one deployed pod. So what will happen, then it will decide, okay, it has one, no, so I'll make it one more over here. So it will make 2 over here, then it will make 1 over here, because my request is 3. Let's say request increase for 4. So then what happens, it will check it out. The kubelet will check it. I have only 2 pods available, then the request pass over here, it will check over here by the kubelet 1 over here, so the count is 3. Then we will add 1 more over here, so it will come with a 2 plus 2, 4. So this is how this everything can be handled. Now the cloud provider API, this is not a very important, this is only use case when you are using when you're using cloud hosted services. Let's say I'm using a EKS, right? EKS service or AKS service for Kubernetes, right? So in this case, the cloud APIs, if you're going with any cloud provider, at the time that APIs you can consume to get the information or fetch of your all the information related to your Kubernetes cluster. Okay. You have any doubt over here in the architecture, you can ask me. For the theory purpose, if you don't understand also, don't worry. In the lab, I will tell you, I will show you how it actually happens. Okay. So anything more questions, please, you can ask now. Anyone?
No, sir.
No, sir. Okay. And my voice is audible, right? It's clear to everyone.
Yes, sir.
Yeah, thank you very much. Now let's go. Let me just close it over here. Okay. So now if you go over here, so as I mentioned, the same will be, let me just from the current slide, right? As I mentioned in the when I explaining the architecture, the components which I mentioned, the same components over here, the kubelet, kubeproxy, and the runtime engine. They will ask you what are the node components, right? What are the worker node components is available. Okay, they may ask you with the worker nodes or nodes. So just you have to say there is a 3 components available in that. One is kubeproxy, one is container runtime, runtime refer to container D of Docker, right? Kubectl is responsible to check it out the health of your pods and pass the information to API server. Okay, so these are 3: kubelet, kubeproxy, kubelet engine. Okay, this already I have explained to you. This everything is going over here. Container runtime, as I mentioned. See, if you check it over here, this is the same container D. Okay, which I have specified over here. Okay, control panel. If you check for the control panel, the master, what component do we have? We have 5 component in that. Kube API, right? API server we have etcd, which stores all your information, okay, information of your process, right? All the information. Kube controller manager, that is responsible to check everything whatever the request has been proceed. Okay, and it is basically as a master of the controllers. Okay, whatever the controller has been, it will take the control of that, and kube scheduler will schedule whatever the request is coming, right? It will schedule, it will pass the information to kubeproxy to schedule in the worker nodes. Okay, so based on our information, kubeproxy is responsible to communicate the health of the pods and the health of your cluster. Okay, ECD, container runtime, is referred to the same thing. Kubelet, as I mentioned before. Okay, these are 3 things. Now let me go with the monitor API server. This already. So the part, let me show the part is the lab, right? Before proceeding for here, I'll show you over there. Okay, so we already discussed this Kubernetes, right? We have this the repository which is in GitHub. This is open source, right? So if you go for here, let me just show you. This is my account, right? In order to proceed this further, right, for the lab purpose, can we take like 5 minutes break? Then we'll proceed with the lab. So the next step, the part 2, we will be proceeding with the lab. Okay, so if you check it over here, okay, this is my the account of AWS, right? The prerequisite in proceed for that, what we required is that we required AWS account. I believe that everyone has a AWS account. Okay, so the first step, what we will do it, if you go for my let me show you this architecture. Let me just, you required kubectl, right? How you're going to communicate with this? Okay. Okay, if in order like if you want to communicate with your cluster, or if you want to create any service, you require kubectl. Okay, you require to install CLI, right? CLI is the command line interface, right? The command line interface you required for Kubernetes is known as kubectl. Okay, so what we will do it in this, we will create one EC2 instance, and we will, let me explain with this step. We will create one EC2 instance. With that EC2 instance, we will install kubectl, right? And we will install another also, like EKS CLI, okay, and AWS CLI. We will require that also. So let me just add it as EKS kubelet, right? Kubectl. Okay. So let me take it Ubuntu operating system. right? T2 migrate is more than enough, but let me just to enhance the speed, I can go with T2 small, just to just so that let me create one new pair, right? Kubectl server, right? I'll go with the PEM key, right? So it is in the downloader, right? By the default, we are selecting VPC, right? In our real time, we will be selecting our organization VPC, right? So this is everything you can check out with the cloud networking and everything, okay? So in this case, I will go with the default. I will enable HTTP. Don't require because we are not going to add the domains. So let's say I will going with the 15 GB, okay? For this, and I will spin up my EC2 instance, right? So let's wait for a few seconds. Our EC2 instance will be up and running. So it is getting initiated. You will check over here. You will be fine. 2x2 check pass has to be passed over here. Okay. So let me just refresh this. Right, I received the IP address. So if you want to access this server, that EC2 instance, you require one SSH client. So in our use case, we are using Mobile Extreme. This is a third-party application, right? Where you can access your servers remotely. Okay. So I'll give the IP over here, and I have used Ubuntu operating system. So in this case, the user will be Ubuntu. Okay, the private key which I have just downloaded, you can just go and go in the download folder, then you're able to find .pem key over here. So if you hit OK, then what happened, it will authenticate my SSH key with the server key, right? The private and public key, whichever is, and it will prompt me that everything is working fine. Okay, so let me just minimize and just zoom it over here, right? So if you check it over here, then you see that we have configured EC2 instance. The first step, what you have to do, you have to switch to root user. The command is sudo su. Okay, you check it over here. I'm the root user now. Before I was Ubuntu user, right? Okay. After that, first step, what you have to do, you have to update the package, because this is a new server, right? EC2 instance which we have used. I will update the packages, so it will update all my Ubuntu and the remaining packages what is available, right? And let me open the document also, which we will be following. And surely you will find this document. Don't worry about that. This document either by the drive, or I'll be sharing in the GitHub repository where you can find it. Okay. So let me just open this file. Okay. See, is text visible now for everyone? Okay. So what are the prerequisites is that, in order to go for this lab, is that you required AWS account, which is free tier. Then we have to install kubectl. As I mentioned in the architecture also, we required AWS CLI. Why do we require AWS CLI in that case is that we are going to use this EC2 instance to check our account details. Okay, account details in the sense what node is available. We want to create the server using this server, right? So for that, you need to communicate. You required AWS CLI to be installed. Okay, we will be using EKS CTL. The reason is that we are going to use EKS cluster, right? We are going to deploy one EKS cluster. So for that, we required the prerequisite that we have to install EKS CTL. Okay, this commands you will find in the document also, or you can go and search. I'll show you from where you will find it, like Kuber EKS CTL installation, right? So if you check the document of this official document for AWS, from there you can find everything like kubectl, how you can install and everything. Just to make it easy, is given here also. What is my operating system? My operating system is Linux, right? Linux ARM64, right? Here the command is given. We are going with the Kubernetes 1.3 version only. Okay. So if you check it over here, this all the command is there which I have added in the document. So you no need to go and check it over here. Why with this only the document you can proceed further. Okay. The first thing, let me just keep it parallel, right? Let me minimize this. Let me keep it over here. Let me minimize this also. Okay. Let me minimize this, right? Okay. The first thing what we have updated, right? So the step what we will do it first, we will install. We have created one VM EC2 instance using AWS account. That request already been cleared. The second step, what we will do it, we will create a we will install kubectl, right? Kubectl. We'll copy this command over here, and I will hit enter. We'll paste over here and hit enter. So if you check it over here, it start downloading all the packages, right? The dependency of the packages of kubectl, everything from the Kubernetes, right? Because this is kubectl. Okay, this download is completed. Then second, what we have to do it, we have to give the executable permission for .kubectl, right? So if you ll over here, you will be finding kubectl, right? So I will give it over here the permission kubectl. Okay. After that, what we will do it, we will move this to user bin. This is recommended. All the things what we have just fetched, we have downloaded from the S3 bucket, right? This is the path. This is of the S3 bucket. In the S3 bucket, they have all the things. Okay, they see EKS.S3. So this all the packages has been stored over there. So if I check with this, is my kubectl been installed or no? Okay, so if I check it over here, it should print me output that kubectl version. The client version is 1.9.19.6. Okay, so our prerequisite of second is completed. Now we required what we required. We required to install this these packages of AWS CLI. Okay, so we will install AWS CLI. Okay, using the curl command, I'm installing AWS CLI. If you ll over here, you will find that AWS CLI.zip file. So in order to unzip this, we required one utility file, that is unzip, right? Because which is not predefined, not installed. So what I will do it, I will take this recommended from the Linux, see how the the perfection of Linux operating system. So when I hit enter, it's suggestion that you need to install using this command. You have to install the utility tool of unzip. Okay, just hit enter, the unzip will install. With using that unzip, okay, we will unzip the downloaded CLI packages. Okay, zip packages, sorry. If you ll over here, I'm finding this one, right? So what I'm doing, I'm just using this same thing and just unzipping these packages. Okay, so it's unzipping everything whatever is downloaded, right, using the curl command in the zip format. So this also done completely. Now what we will do it, I will execute this command. Okay, the script what is there, and I will install AWS CLI. Okay, so if you hit enter, then you can run over here AWS version. So it's showing that you can run, everything is fine, has been installed. If I check now AWS version, you're able to find that the version of AWS CLI. Okay, so it will print me the version. The version is 2.17. It is Python based and the Linux operating system, because we are using Linux operating system. Okay, so this part is also completed, right? We have installed what we have done. We have created EC2 instance. We have installed kubectl. We have installed AWS CLI. The second thing is that we required EKS cluster, right? In order to create EKS cluster, we should install EKS CTL. With this EKS CTL, only after installation, with this EC2 instance, you can communicate with your EKS cluster, okay, which is basically a kubelet, right? Kubernetes cluster. When I'm referring to EKS, please keep in your mind, I'm referring to Kubernetes, okay? Elastic Kubernetes services, okay? This is successful. What we have done, EKS version also I have, right? I have pasted over here. If I paste, then I'm able to find the version of EKS is over here, okay? The prerequisite of mine is successfully done, right? This is successfully done. Now the thing is that what we required is that we required to configure one, right? Let me go over here, one cluster. So what I'm doing, we are using EKS cluster to make it control panel, right? So control panel, what we will do it, I think there is an issue with internet speed. Okay, fine. Elastic Kubernetes Service. This is a service of AWS, okay? This service you can find in major cloud providers, okay? You can find in Google Cloud also, you can find in Azure Cloud also, okay? So if you check it over here, if you hint the cluster, you're able to find that I don't have any cluster over here, right? Cluster reference to that is, I'm going to make it master, okay? Master control panel. So if you go for architecture, so what I'm doing either using kubectl. Kubectl is installed where it has been configured. It have configured in this EC2 instance, which is T2 small. Okay, and with this EKS with this EC2 instance using kubectl, I will create this EKS cluster. In EKS cluster, I will install this control panel, which is master panel. Okay. Then afterwards, I will request this master panel, master control panel to create the worker nodes and the pod and everything. Okay. So let's go back to the terminal, right? And we will go back to our EC2 instance. So you find that there is no EKS cluster available over here. Okay. Now, if you check it here, I have one EC2 instance which I have been converted into kubectl. Okay. Now, what I have required is that I required some specific permissions, right? Specific permissions. I require some specific permissions. With that permission, I will attach, right, to EC2 instance. So let's go and create one role. Okay, I will hit on the role. So if you check it over here, I'm creating one new role, because if you check in the document, what we need to do, we need to create one IAM role, and we need to attach to EKS management host. That means this EC2 instance, I'm attaching some roles and permission so that it has all the permission to communicate with my AWS account. Okay, and create EKS cluster, can configure multiple things. Whatever I am doing, I will be doing with this EKS, this kubectl, which is installed on this EC2 instance. Okay, so let me go back, and what I have to do it, I have to create one role. Okay, with this role, what I will do it, I will use case as EC2 instance, right? Just going with AWS services with EC2 instance. Okay. In this, we required 5 permissions we have to give. First permission, we have to give it administration rights for this role. Okay, so I will attach administration access policy. This already predefined policies are available. Okay, so this is done. The second thing what I required IAM full access. Okay, so I will attach this IAM full access policy, right? After that, I required VPC IAM full box VPC full access, Amazon VPC full access. Okay, I'm giving Amazon VPC full access. Then I required to give it cloud formation, right? Because we will be using cloud formation template. Cloud formation. Yes, this is over here. Then I will add it. I have added 4. One more is missing. The missing is VPC EC2. Let me see what I have added over here up to now. Cloud formation, I have added it. I will add administration. Administration, I have given already. IAM. Okay, IAM, I have given. VPC. VPC, I have given. EC2. Okay, I have not added EC2 policy, right? So in this case, I am adding Amazon EC2 full access. Okay, so up to now, what we have added, we have added 5 policies. This is our pre-request, right, in order to proceed further. So I will give it name as EKS EKS role. To remember the unique name, I will give it as EKS role demo 1. Okay, if you check it over, one policy is created, right? Trusted entities ec2.amazon.com. The policy attached is printing me over here. Kubernetes administration access, EC2 full access, and everything. Just I will create the role. The role is created, right? Is getting created. Okay, the role is created over here. Okay, the name I have given as EKS role based role demo. Then what we have to do after creating this role, I have to give this role to this EC2 instance which I have been using, right, to communicate with my Kubernetes service, right? Just I'm going over here. Here you'll find security. Click on the security. What happened? Okay, let me refresh this. With my internet. Okay. Action. Then you go for the security. modify IAM roles. Then you drop down, you will find the role over here. The role is EKS role demo 1, right? Which I have given just now. This was EKS role demo 1. Do you agree with me? Role do 1, right? That is, I will update this role to this EC2 instance. Okay, fine. This is successfully attached EKS role demo 1 to EC2 instance, that is 746. This is our 746 EC2 instance, right? So if I go over here, now my pre-request is almost complete. Now the second part, what we will do it, we will now proceed and we will create one EKS cluster, right? So if I go back over here in our documentation, you're able to find how you can create. There is a syntax to create in this. So first what we have to do, you have to use the command EKSCTL. EKSCTL utility already we installed, right, in the pre-request here, EKS. So I'm using EKSCTL command, create cluster. I'm giving the name, cluster name. Then you have to specify region, in which region you want to create. Then the node type, instance type, I have to specify. Then I have to give it how many, minimum 2, maximum 2. If I'm not giving minimum 2, then always Kubernetes will pick 2 minimum. Okay. So if you check the architecture also, there are 2 nodes. Okay. So minimum will be 2, maximum based on your use case, based on your application use case. Okay. So in this case, 2, 2, and the availability zones we have to give it. So in our use case, we will go with Mumbai, right? Which is our nearest availability zone for the AWS is AWS. Okay. If you check it over here, that is Mumbai, right? The Mumbai is AP South 1. If you check it over here, you will find the code of this. Why is taking loading time? Yes, this is AP South 1. Okay. In the AP South 1, if you click, you will find a multiple availability zone. Okay. So you will have that knowledge over there. Just I will click paste it over here, right? So what I'm giving is that I'm using EKS cluster creator cluster name. So the cluster name I'm giving cloud asim / cluster 4 region. I'm selecting APS South 1, right? Node time I'm going with T2 medium. Okay. Then afterwards, you can specify based on your application requirement. Okay. My application, it can handle T2 medium. You can give it T2 X large based on your type of your EC2 instance. And the zones we are giving AP South 1, A1 is availability zone of our in the Mumbai region, right? And AP South B. So these are the 2 zones, and we will hit enter. So what happened? So if you printing output, see, so initiated has been done. It's using EKS CTL version 0.118, and it's taking the region APS South 1. It has already taken the public address, private address of these 2 nodes. Okay. Okay. These 2 nodes will be created. First, it will create the node group. Okay. Where it will be print out. So if you go over here, if you check it over here, there is a 0, right? So it has to fresh, and from new one is getting created. So it will show you that, it's processing. See, it started initiating, right? Starting initiated. For 1 second, let me just check my internet because it's taking time. Okay, so it's fine now. Just let me go with it. Now, if you refresh here, it will take approximately 10 to 15 minutes to clear one cluster, because it has to install all the requirements, right? It has to like controllers, it has to create API, a server, it has to create kube scheduler, all the components it has to configure, right? It will take 5 to 10 minutes to up and run all our to create EKS cluster. For that, let's keep this one is in the background. Whenever is printing me completed, we will proceed with this one. With this second step, what we will do it, we will go and we will create one file. Okay, let me just show that file also, right? Let me minimize this. Let me minimize this. Let me minimize this. Okay. Okay. Now what we required after creating this EKS cluster, we need to create the worker nodes, right? We need to create the worker node. We need to deploy our application, right? And we have to do everything. We will mention which container you can use and you can deploy. So we will have overview because it will take 5-10 minutes. So we will not waste our time. We will go switch back because already 9, I think we are 1.5 consumed. So don't worry if the session also get extended. Don't be hesitate or something else. Please continue with this. The main role, the Kubernetes, why it's very effective, you will see in this lab itself. Okay, so stay with the end. It may exceed 5-10 minutes. Let's see, don't worry about that. Okay, but this tutorial will be meaningful. Before that, I'll give the overview of this, which application we are going to host. This is a Docker Hub. In the Docker Hub, I have my account. On that, we have multiple Docker images available. In our use case, we are going to install Bingo application. Okay, the Bingo application, which is already is my application. That means I have worked for this almost like 1 month. I'm the contributor for this also Bingo application. There is two contributor. One is a developer. I'm the another one. Okay, so over here, if I'm logging, no issue. Okay, so if you check it over here, where is the Docker, you'll find that this is Asim and my account name and the image name. This image name we will be using, and we will deploy this container of this application container in AWS, okay, in a Kubernetes cluster, and we will access with internet from this browser, and everyone will access. I will give their load balancer URL. From there you can access and you can see what application does actually. Okay, and we will test case, we will delete some pods. So we will test that is our Kubernetes more enough. When I say auto healing, right, it's supposed to make it count reverse to what we define in this configuration file. So these all things we have to define in one configuration file. That configuration file we will start writing now. Okay, so if I go over, just a second, if I go over here, fine, we're here. So we will write this file, right? The first you have to write in YML, right? You know very well that there is a one yet another micro language, right? YAML file where you write all your configuration. The file name can be defined anything, right? So we will define the name of this file as, let me add the, no, just a second. First what we'll do, the file always start with, we will see first syntax, it start with 3 dash and it will end with 3 dots. Okay, do you just be reference what are the syntax of creating YAML file for configuration of any Kubernetes cluster, right, or any Kubernetes configuration. We required the extension of this is y.yml. So it's written in YAML format. That is new simple key value pair. Okay, where you define name is equal to Asim, roll number is equal to XYZ. Based on this configuration, we will inside. To learn this required like 1 week of time. You can go on any YouTube channel or any resources, you can learn completely. But in this tutorial, we will try to cover some points what we required to create this EKS cluster. First thing what we required API version, right? As I specified before, right? Let me, I think there is an internet issue. Let me turn off my video. Okay. So still is processing, right? We will wait. Let's just proceed. No issue for that. So let's go and write this configuration file. So if you check over here in our architectural drawing, we have API server, right? This is what we are just specifying now. Okay. So what we are going in the first step, we have to specify the API version. API version is V1, right? And we will go with the kind. API version is V1, right? Hit enter. When we'll go with the kind space. And what we are going to do it, we are going to do it deployment, right? Deployment. Then we are going to specify the metadata. Data is known as metadata, right? Let's say what is the date today? Okay, what is the time of the today is a data, right? In the time, if you're going to break down that which second, which millisecond, that is known as metadata. Okay, so just give it over here. Then you have to be notation very clear when you're writing with this file. Just give a name, and I will give is, I'm using Bingo application, right? So I will give it as Bingo deployment, right? Just I will give it name as a Bingo deployment. Then I will give specifications, right? What specific we required, right? Specification, just hit over here. Specification, you have to say that replication As I mentioned that, the replication, that means how many containers you required, right? How many pods you required, right? Replication, I will say as 2, right? Let's go with the 2. So in this case, we have 2 worker nodes, so it will divide one worker node with the one pod. Okay, so replication will be 2. And the strategy, what strategy we are going to use? Sorry, strategy, right? A strategy, then we will give it over here, hit enter. The type of strategy we are going to use for this is a type is rolling update. Okay, whatever we are doing is that, it has to be updated in EKS clusters. And you have to be very careful when you're writing this file. If you find any one minor syntax error or anything wrong with your configuration file, then the deployment will be failed. So in this tutorial, I'll show you how you can write it, but in the real time, I will give you the GitHub link, where I'm going to give you this exactly successful a configuration file, which you can use it and you can configure it. Okay, and you can learn in the separate, you can find in the YouTube channel or any YouTube channel how to write configuration files of YML. Then you can learn. It required 5 to 6 sessions, because you have to be expertise in this, going with all the with all the, how you're going to write everything. This, if I continue, it will take 5 to 6 hours to learn this. Okay, this is a major plate. You have to learn how to write YML file configuration YML files. Okay, the strategy we have already mentioned, and we have specified type also. Then we have to give it as selector, right? Selectors, we will give it as match labels. We are giving the label for our deployment, right? So match labels, right? And the app name, what should be the app name? So I will be specifying bingo app, right? So because I required to give it the bingo, right? I'll give it bingo deployment. No, I required only the bingo. Hit enter. The app name I'm giving as a bingo. Then what template we are going to use it, right? Template. Then in the template, I'm giving metadata, right? Metadata, I'm giving the labels of this, right? Labels. Then we need to give it app name again, right? Because all these services, as we have mentioning, the same. If you're going with the Docker composer as such, you have to write one docker compose.yml, right? Where you specify all the services. Let's say whatever the front end is there, whatever back end is there, what is going to call this service, right? Is going to call the app name of this metadata label of bingo, right? The same thing which happened here, but it is in the deep some specific like depth way, right? So here you have to give the specifications, right? Specification. Here is the important, where you have to specify your container name. Okay, this container name we are giving as what container name? Just have show you, right? I have given the name of this container name as bingo. I will just name this container name as container, right? Then what image do we require? We require the image name, right? So image name, what we will do it, we will fetch from uh, from from the Docker Hub, right? The name of this image name is this one. So we are calling this image, and we are making this image in our configuration file. And with this image, the Docker container will be created, and the Docker container name I'm specifying, it has to be named as bingo container. Okay, and the image name, the image has to be whatever the image you are specifying over in this configuration, that has to be accessible, and it has to be in Docker Hub. Okay, so this request will go to Docker Hub. It will fetch with this name, is any Docker image is available, which is public. Okay, it will fetch the Docker image, and it will create the Docker container of that. If you specify any specific error, like let's say if I delete 0, all right, then it will go and search with this name, is there any container available? It's not available any container, so our deployment will be failed. So you have to be very careful with this, right? With this, right? So you have to check all the names also. Images, bingo. right? Then afterwards we have to expose on the which ports, because this application is a Node.js application. So I know that, on which host does it works. So it works on a Docker port in 3000. Okay. By default, Node.js application works, React.js application works on 3000 port. And this is Docker container. When I'm creating the Docker container, already specified that it has to be acceptable. The port of the Docker container has been specified as 3000. Okay. This information, you should have this one. Okay. So now this everything is created. What we have done is we have created we have written the one configuration file to create a Docker container in the pod, right? In the pod. So if I go for the architecture, what I have done, if you zoom, let me zoom it over here. The Docker container image I have already specified. I'm creating that container in the pod, so it will be working in the Docker in the any worker nodes, right? In the worker node, any one of the worker node. But do that worker node have the access of internet? No, it don't have the access in the internet. You cannot access this one. In order to access this our application from the internet, or it to expose to the world, you required one service. With that service, you will attach one load balancer. Okay, with that load balancer URL, you can access when it's successfully deployed onto Kubernetes cluster. So that configuration we have not specified up to now. So for that, we will write one more block. It can be two files, it can be one file. So in our use case currently, what I'm doing, I'm just creating only one file, right? In that one file, I'll be adding these points. Two things. First, for the container specifications, which container specification, which image to fetch to Dink, we are deploying this container, right? And the second is that we are going to access, we require the access from outside of the world, right? That is internet access. If I'm not specifying this second block, right, I cannot access this application from browser. Okay, you got my point. So in this case, whatever second step, what we require the metadata of this service. So I will use metadata name as a bingo service. Okay, in the deployment, I've given deployment. In the service, I will give it as service. This configuration is for the service. Okay, this is for the deployment of our application. Then afterwards, I think I have, okay, service I have already given. Metadata is bingo service. Then afterwards, what was the third point? We require section, right? In the specification, we will use this second point, right? The second block, we will give it as specification. In the specification, you have to give it a type, what type of this service we are going to use. We are going to use what kind of service, right? So in this case, there is multiple type of services from which you can access your application. In our case, we will be using load balancer. We require load balancer to access our application, right? Load balancer our application. Okay. So after that, we will say that, we have given everything. The selector we required, right? Selector, in the selector, we will specify the app name, because on which app name you're going to attach. So app name you already specified over here, bingo, right? So just we are making communication between service and app. On which service this service has to initiate on which application, right? So app I'm giving as bingo, the same which I have specified over here. I'm calling from this service to this application. Okay. So bingo, I have given app. Then afterwards, I need to specify the ports. Port, I'm giving port, right? Port, I have to specify 80. This I will explain you now. Don't get confused for this. Why I have given the port over here 3000. This is my application port on which my container will be exposed. Okay. The load balancer always work on 80 ports. If you don't have the information about the networking, so you can just for you remember that load balancer always listen on port 80. So for that, I'm saying that, load balancer to listen port 80, and I'm giving the target also. So as if you remember that while creating the Docker, we give as Docker run -d-p, right? We are giving the host IP, and we are giving the container IP, right? This is how you make your container, right? Docker container from the Docker image. Here you are giving image the host. If you're giving EC2 instance, the same I'm giving over here. This is my host 80 port. That is the load balancer. Then I'm giving the target. The target is my the container IP. The container IP the port is 3000. Okay. So the same way I'm giving over here. Okay, the strategy is different, but the concept is same. So after that app I have given, the port I have given, everything is done from our side. So just what we will do it, we will save this file with the name home over here, and the file name I will give it at manifest.yml, right? So let me go to the desktop and manifest.yml. Just I'm giving my manifest.yml, right? So I have saved this. Let me save this file. Okay, so this is file, my file is already saved, everything is done. And let me delete and everything. Okay, so see, it's showing me the error that because I have not used dot three dots, right? As I mentioned, if you check it over here, it was showing the red, now it has been closed. So what we have done, we have started with three dash, then we have gone with the three dots over here. Okay, three here, with the three dash over here, and the closing go with this one. So my configuration is file. So let's go and check. Yes, if you check my EC2 instance with the creating of the configuration file, our EKS cluster has been created. Now how do you validate this EKS cluster, right? You may ask me that how you can go and check, sir. So you can go with the cluster. Okay, if you refresh here, you'll be status is fine, you'll be status you'll be fine mentioning that this is available now, right? Yes, the status is active. If you check the cluster name over here, you're able to find that, there is an endpoint has been given. It has created 18 minutes ago, which is latest resources. If you check it here, there is no pod has been deployed, right? We have not deployed anything up to now. Just we have written in the configuration file. We will deploy now. Okay, so just it's empty, right? Compute. If you check here, the compute, I don't have anything because I have not created any worker nodes up to now. Okay, the group is given everything, right? The Kubernetes version, this will be the interview question. If you know the Kubernetes, they will ask you on which version do you have worked. So you have to say the version is 1.30. The latest version is 1.31, but still is in, maybe it's not adapted by any cloud provider, but no issue. You can say below 1.30. You can say anything. That support is giving that support will be up to 28 2024. Okay, the provider is EKS because we are using EKS cluster. Okay, now everything is fine, we have everything. EKS cluster master, this is only the master. Master is everything, this is the mind behind, this is the brain of the master, right? Networking, if you check here, the networking has been created. They have creating four subnets. In that, the cluster security group is created. API server endpoint is created, right? Cluster IPv4 is given, but this is don't have any access outside of this cluster. Okay, you cannot access everything. Access over here, right? Everything is that. Now the main thing is that what we required is that we required the nodes, right? The worker nodes, and we required the pods, right? To create this one, we required first we have validated everything using the GUI, right? We have going to the AWS console and we have checked everything manual. Even we can check with this with everything with the CLI of AWS. Okay, so with this, what are the commands you can use to check this one is, you know I'll show you that also. Let's say we want to check what service do we have, any service, kubectl, right? SVC. If you hit enter, it will prompt you that, kubectl, sorry, I have mistyped. It should be kubectl. It will prompt me that is service, anything service is installed. No, kubectl, you mean command CVC, right? So it's prompting me, let me say, sorry, I have supposed to get use the second argument, right? Get CVC, right? If you hit enter, it will show that there is nothing, only this is only the cluster IP. This is not accessible publicly, so just avoid this. So it's not useful, this is only for internal purpose. Okay, if you see the external IP, this is none. Okay, so it's saying this one, right? After that, if I want to check it at cube CTL, right? Get pods, right? If you hit enter, it's showing that what do you mean by this? Oh my goodness. Cube get pods, it will prompt me that there is no resources has been created. So whatever you are checking with the GUI, you can even check from the CLI also. Okay, this commands is already given over here. Okay, if I check over down, right, This is over here, right? Get nodes, right? There is no nodes available. Okay, so this is fine. Now what we will do it, we will go and we will just open the file, right? What we have created, that manifest.yml, right? Let me just copy everything over here. Then I'll go to my root over here, my EC2 instance. Then what I will do it, I will name over here, I'm using nano editor, right? Manifest.yml, because I have to create this file in my EC2 instance, right? Then I will paste everything over here which I have copied. Okay, if you check it over here, whatever I've given, I have given API version. First, we are going with the deployment block, right? Where we are using Asim Akram 19 image name, okay? And we are container port is 3000, we are defining over this, okay? Then we are creating one service because we require the access from internet, right? With that access with the internet, let me just on my battery, right? Okay, battery is up, okay, fine. Then service is up, right? We are creating the service, we are specifying the service name, we are specifying the which kind of service you required load balancer service, okay? The name I'm giving bingo app, which I have specified above, right? Then I'm giving port 80, I'm mapping this 3000 port to 840, right? Control Y and save, enter. If I cat over here, then I should be able to see the file configuration what I have given, okay? So you should be able to be very careful with writing this configuration file, okay? Whatever you are doing, you have to check the spelling mistakes, the syntax, notations, how you're going to specify. It should be space between these, key value things. So after this, this is created, what we required is that, after, let me go with the document. Now what we will do it, we will just hit the command and we will create this configuration file, right? So if you want to execute this configuration file, you're required to use the command as kubectl, right? Kubectl apply, and we'll give F for application, right? And the main the name of the configuration file, okay? So let me hit enter. The configuration file which I have written over here, this manifest.yml, right? I'm calling the same file to create my resources. What we are creating a Docker container, right? We are creating a Docker container and we are creating multiple pods, right? We are deploying our application into the pods, right? After that, what we are doing, we are creating one service because we require the access of our application globally. That means it can be accessed from anywhere over the world using my URL, okay? So now if you see that deployment has been created, the service has been created. The name what we have created, bingo deployment created. If you prompt there is any error, you have to check this manifester file, okay? And you have to fix any syntax error from that files, okay? You can take the help of you can take my GitHub repository to avoid this thing, or you can use any if you don't have the knowledge of YML, you can use any AI tools, right? You can use ChatGPT, you can use black box AI, which will prompt you better output to fix these errors, okay? So now what happened, we have successfully deployed two things. One, deployment of our application. Second is service, right? So if you check over here, right, if I go over here, you're able to find that, let me just show you one more thing. If you refresh over here, see, let me show you this. How many EC2 instances do I have now? I have 3, that is old, so not related to the. I have only one which I have converted into kubectl. Now if you refresh here, do you see any new instances right here? Let me refresh this. Yes. So let me set with the name. See, if you check it over here, you're able to find there's 2 worker node has been created using configuration file. The cloud asim cluster 4 with the name, which because I have given the cluster name, right? So I'm deploying worker nodes in that cluster, so it's referring to that cluster name. The cluster name and the node 1 with the reference tag is 32BC and the second one 32BC, right? So if you check the down the instance ID, you'll see that there is 2 different instances. One is 441A and 4840E, and 2 are T2 medium because we have specified T2 medium in our configuration file, right? If you check it over here, manifest, did I specify anywhere T2 medium? No, I have specified in Let me show you that. Where was the setup? Yes. Here already specified that to use T2 micro, T2 medium, right? Where I have specified that label Java. No, just a second. Template metadata container. I have missed out one point where I have already specified this requirement. T2 micro cluster. Yes. See, if you check it over here, while clearing the cluster, I have already specified that node type has to be T2 medium only. Okay. So in this case, this has taken from here itself, and it has been created is T2 medium. Okay. If you check it over here, node 2, two nodes has created with the two different instance ID, and they have different instance type of T2 medium, right? T2 medium, that is up and running, the state is up and running, right? Now this is GUI access, right? It has given some public IP, right? And if you check it now, you should able to find one load balancer has been created. Okay. Load balancer, right? No, just I'll switch it load balancer. So in my account, there was no load balancer, but now it has created one load balancer. If you refresh over here, it's loading, taking time. So it will prompt me one load balancer is over here, right? Yes. See, one load balancer has been created. VPC is given to ability zone, and it is created in which time? Let me zoom you. Okay, in the 17th August, today is 17th August, the time is given 19, right, which is a 7:45. So it's created this now, right? I can validate that yes, it has been created now. So what do we require now is that it's listening with this, and it's checking the health check. Let me check health check. It's saying that in 10 seconds it's checking my EKS cluster health check. Okay, so everything is there. If I go over here, what do I require to access this cluster, right? So I required a DNS of this cluster. So DNS name of this cluster is this. Okay. So now with this DNS name, if I share with you, you can access anyone, everyone can access our application, which is successfully deployed. Let me first validate, and I'll share you with you. Okay. So it's taking time, right? It's loading my application. The request will pass to AWS. See, if you check it over here, you'll finding that my application is accessible. That is accessible with load balancer. And our region, what we have selected, that is AP South 1. Okay. So this link I'll be sharing you now in the in our chart. Okay. Just check your chart, right? And try to access this. Okay. Let me pin this. Copy this same from A to M, right? And paste in your browser and try to access this application, and let me know that are you able to access. Now this application, if you're referring to that, I know what kind of application is there. So this already I have, I have in my YouTube channel. Okay, if you check, there is a one complete tutorial in that, what is it actually bingo application, how you can test it locally, how you're going to integrate with multiple DevOps tools. Okay, whatever my application is, that code is passing my quality gate or no. Okay, that the application is written in Node.js, as I mentioned that. So we have to install Node.js dependency. Then it's going with that. This is a security tool when we are specifying with the DevSecOps. Okay, in the security there are multiple vulnerability application check application. That is, one is SonarCube, one is Trivi, where you can scan your Docker images and the file of your source code, and you are using OPAS also for the check the history of your code. Is there any vulnerability that you can fix it? Then we are creating a Docker image of that application bingo, that Docker images which I have showed you in the Docker here in the Docker Hub, right? This is the same image which we have created using this this tutorial. Okay, so I have scanned after creating Docker container of using 3-way application, right? Even the vulnerability or the dependencies of my application is expired, we can upgrade to that. We are deploying using Docker deployment. But in this case, in this tutorial, we have not used Kubernetes. Just to explain this now, I'm using this Kubernetes now. Okay, so you can access with this anyone, right? Let's say asim.com. I can add this. I have this URL, right? This URL I can go and add in any one of my application, right? Like DNS, right? You're able to find this application accessible anywhere. So let me try with this. I can make it or no. Let me try. Okay. I have my domain over here, which I've used for the total purpose. Can you give me the feedback? Is my application accessible on the internet?
Yes,
Yes,
sir,
sir.
it is accessible, sir.
Accessible internet. So let me just, instead of that, let me add the DNS, because we are not going to provide any URLs or what I say, we are not going to share your IP or the load balancer to the public, right? So in our case, let me say, where is the DNS records? Just a second. Please, can we extend 10 minutes more? Students, can you please permit me so I can show you that part also?
Sure, sir,
Sure,
not
sir.
an issue.
Yeah, sir, sure.
Okay, because what I wanted to show you, that you may have seen a lot of tutorials, right, where you will be finding URL, you can access everything, right? In the real time, your company is not giving you the IP address or a DNS. Okay, let's say google.com. Google.com is giving you the domain name. They're not giving the IP address and say, please go and access my IP address, right? Or load balancer access. So in real time, they are giving one domain name. Domain name should you have to buy from the providers. It can be GoDaddy, AWS, any providers which are providing, right? You can do it. You are coming to this application, right? So if you check it over here, you can give it anything, room ID. You can give it Asim Akram. You hit enter over this. Okay. So you are into the chart now. So this is a real time application, right? You will, if you check my YouTube channel, on the channel, this tutorial, you will see complete how you can use it. Even you can play the game on this also, right? If you go with the create room, let's say ID 1 2 3 4 5 6, right? Create, it will take few minutes. Start game, you can just hit enter. This is a game which is bingo. You have to be knowledge of this. Okay, you can play this game with 2 users also. Okay, now the thing is that we have done some of this access, right, on this. How do we access now? How we can get the logs of this, everything what we have initiated? So in this case, now let's go and play around with this, say that auto healing of the Kubernetes, right? What do you mean by auto healing of the Kubernetes, right? So let me close this part. Do you remember that, before configuration executing or creating manifest file, while I have given some commands, right? I was using kubectl to get the update of my services. I was prompt that there is no such services. So let's get validate with this one now. See, it's showing that the bingo service is running. Let me zoom out so you can have the clear view. See, is saying that bingo service, one service is getting, that is exposed type is load balancer, the cluster IP is this, and this is a load balancer URL which I have shared with you everyone, right? So this is how you can access. So now it's prompting that is successfully done. So I'm getting this prompt out, right? Then afterwards, if I check does I have deployed anything, I have deployed bingo, right? I have deployed the bingo application, so it has to prompt me that the bingo deployment is done successfully. And what criteria we have passed? We have passed 2, right? In the configuration, we have mentioned that it has to replication of 2, right? If we check my configuration file, I have given replication is 2, right? So it's showing that 2 replication is there, that is available, that is up to date, and is ready and is healthy, right? The age time also is given that you have done this deployment before 15 minutes. Okay, so this also is successfully done, right? Then afterwards, I want to get the pods. Okay, so if I want to check out the pods, right, I can use the command, right, kubectl pods. So I will just paste it over here, kubectl pods. So the pods is two, right? I have mentioned two replica, right? There is one two with the k8r vfr, 112 running 00 and h time is 2. Now the point is that we will validate that as in the specific starting of these sessions. I have specified you that the Kubernetes has auto healing, right? So how does it define how in the real time it's working? So this part we will check it now. So let me go with this. And now if you check it over here, in which worker node that this pod has been deployed. If you hit enter, that is showing that in the worker node of K8AR, one pod is deployed, one VGD VQ, one pod is deployed. How does it happen, right? How it happened in the architecture? If you check it, the architecture of the Kubernetes, who is responsible for that is responsible to the kube scheduler. Okay, kube scheduler with the use of Kubelet, it will check in the which worker node is a space or it's available, right? Let's say one is there, so it will distribute the loads while the creation. It has created in worker node one pod, another pod in this one. In the pod, one container I have, right, of my Bingo application. So this is point the scheduler will decide, and the kubelet will check it out, the health and everything. It will revert back. Now the thing is that the health of my pod is showing that it is healthy, right? So what I will do it, I will delete this I will delete this pod, right? So let's take this command, right? Deployment kubectl deployed the pod and the pod name. What is the pod name? What we have given, the pod name is over here, right? With this print, with the kubectl get pods command, it has printed that two pods are running, right? So I want to delete this pod, right? Paste. Okay, let me hit enter. Deleted. It's printing that this is deleted now. So what action has to be done now by the Kubernetes? So let's check this scenario. Now what happened? I have deleted manually, right? But it can be any scenario. It can crash my application. Let's say my application 1,000 user came into this, and the type of instance which I've selected was T2 medium, right? It cannot handle. At the time, my resources have been crashed. Let's say CPU or the memory crashed of that of EC2 instance, right? At that time, what happened? The kubelet will check the health of my pod, and it will revert back to a kube API. Then kube API will get back to the kube scheduler and say that, hey, here's some anomaly is going to happen in the worker node, one or two which are happened. The same scenario is over here, right? So it will revert back the information to kube scheduler. Kube scheduler will revert back to the kube API, say that, okay, this happened. Please go and create one more one more pod in the available node. So wherever the vacant availability is there, node is there, please create one more pod over there. Okay. So now it's supposed to be in our use case, right? It's supposed to be only one pod, right? Because in this two, I have deleted this pod, right? Do you agree, everyone?
Yes, sir.
And the time was there 15 minutes, right? Now what I will do it, I will use the same command. When I say auto healing, then I don't want to go and create one more pod. It has to create automatic. Okay, so that validation of Kubernetes will validate, right? So if I hit enter, so how many you are getting? What is output? 1 and 2. And what is the time of this check over here? This is 97 seconds. Do you get my point? One was there 15 minutes. The second one is already working. The one which I have deleted over here, this automatically, it has pinned one more pod, right? It made available. So this is what Kubernetes will do. Okay. Kubernetes part is to delete whenever your pod is crashed, or it's got any DDoS attack, anything happened, it got crashed. What will do it? It will spin up one more pod. In the pod, there is a container. End of the day, our containers will be up and running. Okay. So now in use case, what we will do it, we will delete two pods also. Okay. First, I will delete one pod quickly, right? Just take the last name of this, right? 72, I'm deleting it, right? Then afterwards, I'm deleting it one more pod, right? The pod name is Bingo VQ, right? So now supposed to happen, what happened? Let's say my application got crashed, right? So what happened? The Kubernetes will check everything, as I mentioned in the architecture also. It will spin up immediately after this. Now what happened? We will check and validate that is my two pods also created automatically. Hit enter over here, just hit enter. So now you're seeing that yes, two new pods had been created, and the age is one is 33 second, one is 20 second. This is done automatically. Okay, it's not created manually. In this case of Docker, in the Docker, I have to go manually and check with the Docker logs which Docker ps command, check a hyphen a or ps to print it out which Docker has been stopped. I have to restart it. This is how the Docker is evolved and adopted in IT industry. It's known as auto healing. Okay, the use case which we are handling, one of the use case is the auto healing. Okay, but there is multiple use cases in Kubernetes. It can be auto scale. In that auto scaling, you have to write some of the configuration that will take a lot of time. To learn the Kubernetes, at least you require 10 to 15 the sessions of the Kubernetes, right? And even there is a certification of CKA, if you are aware of, right? Kubernetes administrator, right? Certified Kubernetes administrator. So that with that course also you can get all overview of the Kubernetes. Okay, with this one. Now the point is that where it has been created, right? These two parts. So how do you want to check it out with this command with the same thing? Paste it over here, cube pod 0. Okay, so it has created in worker node 1 and worker node 2. This is a pod name, right? Z is a pod name, and where it has created in the pod node 1 and node 2. That is worker node 1, worker node 2. Okay, this is the point. Now if you say that Asim, you have created only 2 of your pods, right? How you can increase without increasing configuration file? So you can use the command and you increase, instead of 4 pods, 2 pods, we can create 3 pods also. Okay, that command I will show you over here. We have already added for our practice. Okay, so you can use this, and I will show you now that instead of 2 we can say that replica please create 3. Now in this 3 case, what happens? One node will get 2, one node will be working, one have, right? 1. So if you check it here, it has been scaled. Okay, if you check that, it's showing automatically saying that please, we are using kubectl command, just saying that please scale our deployment below. So whenever I am using the kubectl command, so now it has to prompt me how many pods. It has to prompt me 3 pods. See, 3 pods is available. Okay, 3 pods are available. Now if you check it over here in the one worker node, right, you have only 1 pod. In the another worker node, which is 27, this is worker node 2, right? You have 2 pods. Okay, see, the latest one pod is created in worker node 2. Who is responsible to create this all things? Okay, Kubelet is responsible. Okay, the kube scheduler will give the information, and kubectl will check all the things, and we will say this node has the space or it can accommodate this request, and it will be handled. So everything will be passed a kube API service request to kube API server. Okay, and the internet also which we are accessing, you are accessing with API server itself. It will check and will look forward to the with the load balancer, right? It is forwarded to the request to the node 1 or node 2. Okay, you got my point. Now what happened? We will revert back our deployment. Say, right, which have done 3, right? We will do it 2. Okay, so to do the 2, you can use the command itself, the replication of 2 itself, right? So instead of using the same command above, I will say replication please do 2, right? Okay, now do remember that Kubernetes is always free, but the service which you are using and the infrastructure you are using from AWS, that is always going to cost you. Okay, so roughly pricing, if you ask me, Asim, what will be the rough price of EKS clustered hosted on AWS? It will will cost, based on your configuration, it will cost you $100 per month to $100 per month. Okay, in one use case, it can expand based on your resources, what you have specified in the configuration file, it will be up. So if you don't delete your after creating this tutorial, right, completing the session, you will be charged. This is not free. Please don't forget to delete. If you're following the tutorial and creating all the things and deploying application, please delete first the pods what we have created. See what hierarchy we have done. We have created one. First step is EKS cluster, right? EKS cluster. Then what we have done, we have after creating EKS cluster, we have created the services, and we have deployed the our application, right? So second step, we have to go in the reverse while deleting. Okay, first you have to delete it whatever the resources you have created. Resources in the sense you have deployed the application, you have to delete. You have to delete the services, that is load balancer you have created. Okay, the command which we have to use it, that's using, you can use kubectl delete dash that command. So if you print over here, kubectl command delete all, so in our resources whatever we have created, it will delete everything. So it will take all the things. If you check here, the port is getting deleted because I have two ports over here. Okay, I was having two port, that is ZS and SV. This was deleted because I have replication of two, and it's saying that Kubernetes please delete the service also. Kubernetes deploy.app bingo deployment is also done. Now if I prompt, if I ask, if I want to check is successfully deleted now, no. So I can use the command kubectl get ports, right? If you hit enter over here, so it's saying that no resources found because we have deleted all the resources, right? So this is how you're going to delete all the resources you have created inside the EKS cluster. That means the nodes and everything, right? After deleting this one, okay, after deleting this one to avoid AWS video, I want to delete the EKS cluster also, which I have created. Okay, so if I check over here and let me load balancer, let me go for EKS cluster. Let me refresh that and check it out. We have two worker nodes available again, right? Because we have created during this cultivation, right? So see, we have deleted the pods, right? If you go and check over here, if you go for the resources, see pods are 0, right? But we have worker nodes available, right? If you check it over here, instead also is showing two worker nodes. How you're going to delete this? Okay, while creation of this EKS cluster, I have used the command, right? The command was EKS create cluster name, the name of the cluster, region, everything. Okay, the name, instead of create, you have to use delete itself. You hit enter, it will takes like 5 to 10 minutes, and it will delete everything. But this prompt action will be reverted over here. Okay, if I go and refresh my cluster over here, let me refresh, it will take few seconds. It will say that deletion is taking place. Okay, till that we will go and we will have the overview of our sessions. Okay, so what we have covered up to now is that let me go back. So what we have covered, we have first said what is the Kubernetes, right? And Kubernetes, one more point, let me add, I missed out that Kubernetes also referred as K8s. Okay, K8s. In the short term, it's also is referred as K8s. Okay, why you're going to K8 as, in this, if you check the letters 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? These are 10 letters Kubernetes. That in between is the 8. So in this, instead of this, they are writing 8s. Okay, so this is how this is referred. If you see any document is referring KS, that is Kubernetes. Don't get confused. And this is derived from where? Do you have any idea? So let me add these points also. We are very we are honored or privileged to give this kind of things to write. If you're let me add, maybe you are all the students, right? You are okay, you are studying in fourth year, or you may be passed out. You're very young, you're student of 2000, right? Maybe, if I'm not wrong, 2000 or 1990 plus 1990. If you go back in 2000, there was a date in the system of PC. There was date of 1999, right? After 1999, the 2000 came. At that came of 2000, the all the system PC got crashed. Okay, so it was not updated with 2000, so they don't know how to upgrade at the time. They faced global impact of this. There was an Indian person, I don't remember the name, who made this available with the name as 2K. 2K, okay, 2K1. You remember? You can go and search on the Google why 2K way came. So at that time, it was referred as 2-2-2 2K1. Okay, that means let me just write 2K1. That means it is 2nd February 2001. This was given by Indian. So this privilege we have with us. The same thing they are copying now. They are just they are copying and pasting over there. It's also right like Kubernetes. You can check and you can check the history of this one. As an Indian, we have given a lot of things to the IT industry which you cannot even imagine. Email was initiated by the Gmail, or first email was initiated by an Indian. Okay, so this is what we have given to the IT industry. We have given a lot of achievements to the IT industry. We are proud to be Indian. We are proud to be in the IT industry. The IT industry cannot survive without the support of with the Indian. If you go for the major players of IT industry, Google, if you go for Microsoft, you will see the top player with the Indians. So it's an honor, it's a privilege. Being an Indian, you have to be always been to that mark. So this is a way you will see on the YouTube channel. You'll see a lot of Indians, sharing your knowledge and everything. So you should be mark up to that phase, to the level of that. You have to go exceed to that level from there. What the base have been set by Indians. Okay. So I hope you in the 5 to 10 years in the future, you will be achieving that phase in your career. Don't worry, there is nothing impossible. If you feel hesitation learning this also, please see this video or any another video 2 to 3 times, practice yourself. There is nothing, everything will be difficulting until you don't know. Okay, once you know this one, practicing, everything will be easy. Being an Indian, I'm saying you that you can do everything in the IT industry. There is nothing. Even you have a lot of community support of AWS or cloud support, DevOps support. You will find on YouTube, on you'll find on the LinkedIn. You can hit any developer on the content creator. You can ask them for help. You will find everyone helpful. Okay, so let me go over here. So it's still taking over here. So maybe take for more 5 minutes. Let's discuss this point also. So I have added the reviews over here also, the links, right? You can go with this Kubernetes course. You can active Kubernetes core. You can check it out. This everything is free. I will add more this YouTube channels links, and I will share you on the GitHub link how you can find this one, right? I will try to share with your admin of this host, or else you can go and search over here. Sim Akram 19. See, this is my GitHub repository, right? This is the latest where I update always. So here I will update everything. I will create new repository with the EKS because I have to authenticate my login on this system, right? After this, you can find everything. Now you are curious that where is a repository of this which I have showed to you, right? This is over here. This is a bingo, right? If you check in the Bingo, I have all the code related to the Bingo application, which is written in Node.js using different stacks. If you go over here, we have two contributors, as I mentioned, which is Andrew. This is written in a different language, maybe Rus language, something which I have converted to the English. Okay, making some efforts. I tried. I'm not a developer, but still I tried something to do it, which is written in English. This is the reason you are going to see some of the homepage content in the English, right? The welcome content, username create, it was in the German language or something another language. Okay, so you can go and you can fork from here, which have we already have forks 14, right? You can give the star also if you feel the worth it. Okay, you can create this one and you can make it helpful. Okay, you can contribute if you feel that something is missing inside my directory, like Kubernetes file or something else, which will I will add in the future. I have a development branch also in this, right? Development branch. You can just give a one request, pull request, and merge request. You can initiate. I can do that one. Try everything. You can find 100 of videos available on the YouTube. You can check it out. It's taking 4 more time. Okay, supposed to time. You have to be patient. And one more thing is that I want to add it. See, I will show you with this cluster itself. So it's had been initiated, right? With the closing time. Just let get fresh. Still is taking time. Yes, see, the prompt is getting deleted. Okay, based on your query, our tutorial also is coming into conclusion. So we have whatever we have created has been deleted. Don't forget to create delete this EC2 instance also. This you have to delete manually because we have created manually, right? In this one. If you refresh over here, you will be seeing that all the instances has been deleted. Only one instance which I am be using this one. This you have to delete by using manually. Okay, you can go and delete it after completing your practice. Okay, let's wait. See, all has been terminated. Let me just use this and terminate this instance, right? So this has been terminated. It will prompt exit. Okay, so thank you very much. You can share this your insight, how you find this tutorial. You can share with that. If you have anything in 2-3 minutes, you can ask any questions or something you feel hesitations, or else we can conclude this session. Yes, please. Anything? Any reviews?
The session was very interesting and good, sir.
Okay.
It was very insightful for us to learn new things which we didn't learn, sir.
Okay. Thank you very much. Huh? Thank you very much. Please don't forget to be updated to the industry. Okay. Thank you very much. We are concluding this tutorial over here.
Sure, sir.
Thank you
Thank
so
you.
much. It was very informative.
Thank you, Vicky, giving me opportunity. Thank you, Saundarya, giving me opportunity. Okay. Thank you very much.
Thank you, sir.
Okay.
Thank you so much, sir.
Sounda, you can conclude the session with your vote of thanks.
Am I audible to everyone?
Yes.
Yeah, you are.
As we wrap up this insightful session, I would like to express my sincere thanks to Mr. Mohammed Azim Akram for sharing his expertise on DevOps tools, that is Kubernetes, with us. Your knowledge and experience has provided us with valuable perspectives that we can apply in our own work. A big thank you to our organizing team at the Placement Empowerment Program and the Cloud Computing and DevOps Center for making this event possible. Your dedication is truly appreciated. Finally, thank you to all the participants for your active engagement. We hope you found the session enriching and look forward to seeing you in the future episodes of Cloud and DevOps Masterclass series. Thank you and have a great evening.
Thank you, guys. Thank you very much. Thank you.
Yes, sir. One last thing. Before
Yeah.
we wrap up, we would like to have a group picture. I request everybody to turn on their cameras, please.
Yes, please. Just a second. Let me take this also from my end because I want to add this photo. Thank you.
Thank you, sir. I hope the pictures are taken.
Yes.
Okay.
Thank you, sir.
Thank you for this session,
Thank you,
sir.
guys.
Thank you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.